Hello everyone, welcome back to Diksha Karnataka YouTube channel. And because most of you have requested the chapter Moving Charges and Magnetism is there in the syllabus for your first unit test, so I am going to discuss the moving charges and magnetism today. Also Sunday I will come live to discuss some other important questions, so be there. And if you are watching our channel for the first time, I request you to subscribe to our channel. The subscribe button is down there, so click on the subscribe button and also click on the bell icon so that you don't miss out on any notification coming in our way. Also, if you want to download the PDF of this lecture also and one more lecture that I did previously, if you want to download the PDF notes for that, then you have to join our WhatsApp channel. The link of the WhatsApp channel given in the description section of this video. Click on the description section of the video and there you will find the link to join our WhatsApp channel. There you will get all the latest update, all the important news, and whatever we are doing. Some polls also we do from time to time to know what your preferences are. So that's why I request you join our WhatsApp channel. That is very important to stay updated. Now, moving charges and magnetism is an important chapter, and some of you have this chapter in your unit test 1. So that's why I am going to discuss all the important questions from this chapter. Let's start with the MCQ. As usual, we are going to discuss the MCQs from this chapter. If a current is flowing in a straight wire parallel to x-axis and magnetic field is there along the y-axis, so current is flowing in the x direction and magnetic field is along the y direction. Okay, so we have to find the wire experiences a force in x direction, the wire experiences a force in y direction, the wire experiences no force, the wire experiences a force in z direction. So now you have to remember that the force acting on a current carrying wire is given by B in terms of vector B I L cross B. Okay, you have to write the vector form to find the direction. Okay, remember that BIL sin theta, or in terms of vector it is L cross B. Now it is important to know. Why it is important to know? Because you are trying to find the direction. Now if you see that this is a cross product. Cross product means if two vectors are perpendicular, this is not 0. If it is a dot product, then perpendicular vectors gives you a 0 value, right? So if you remember no work force. Similarly, when you are doing the cross product of two vectors, two perpendicular vectors give you the maximum value, because sin theta sin 90 is 1, that is why it is the maximum possible value. Now what is first? L is first. L means the direction of the current along the length of the wire which is carrying the current, and B is the magnetic field. So if you see that this is the direction of current and this is the B, so you have to curl your fingers towards the magnetic field and that will give you the direction of the force, right? So force is basically, if this is x, this is y, this direction gives you the z direction. So obviously two perpendicular vectors cross product, the resultant answer will be perpendicular to both of them, so it will be along the z axis, right? Z axis generally in 3-dimensional we denote it like this. This is the z axis out of the page, right? So the force acting on the current carrying wire in this case will be along the z direction. You have to remember that two perpendicular vectors always acts perpendicularly, and that they will be mutually perpendicular to the direction of the force. It is very important. Now Lorentz force is the force on a charged particle moving in a region containing only electric field, only magnetic field, both electric and magnetic field, only crossed electric and magnetic fields. So option D, it should be here anyway. So you have to understand that Lorentz force is given by, what is the expression for Lorentz force? Q into E plus V cross B. right. This is the expression for Lorentz force. So, it depends on electric field and depends on magnetic field as well, and there is no such cross electric field or magnetic field. Any electric and magnetic field, it will always depend. So, Lorentz force is basically both electric and magnetic field. Cross electric field means what? Cross means only when electric and magnetic field are perpendicular. If they are perpendicular, they are called cross electric and magnetic field, but that is not the case over here. It can be, it is true for any of the magnetic and electric field, right. If there was only cross thing is possible, then it would have been clear from the expression that only except the crosses it will be valid, otherwise it will be not valid, but it is valid for any magnetic and electric field. So, option C is correct in this case. This is a clever question. Be careful such clever questions, answer them thoughtfully. Next question, a moving coil galvanometer can be converted into voltmeter. So, galvanometer to voltmeter. So, galvanometer to voltmeter, what do we need? We need resistance, high value resistance in series. We need high value resistance in series. So, a high value resistance in series with the galvanometer. High value always in series, low value always in parallel. Galvanometer to ammeter, if you are converting galvanometer to ammeter, it is a parallel low value. Okay, it is parallel low value. It is in series high value. That is how you can remember pictorially. Next, force on a charged particle moving in a magnetic field is maximum when the angle between the velocity of the charge and the magnetic field is. So, force on a charged particle moving in a magnetic field is maximum. So, what is the expression? Again, force is given by due to magnetic field, magnetic force is Q V cross B, right, or scalar form FB is given by Q VB sin theta. So, when the force will be maximum? Force will be maximum if sin theta is maximum. What is the maximum value of sin theta? That is 1. When the maximum value is possible? The maximum value is possible when the angle is 90 degrees. Sin 90 is 1. So, that is the maximum value. So, force will be maximum when the angle is 90 degree, force will be minimum when the angle is 0 degree, right. A charged particle is released from the rest at a region of uniform magnetic and electric field parallel to each other. The particle will move in a helix, in a circle, in a straight line, in a cycloid. Let us see. So, charged particle is released from the rest at a region of uniform magnetic and electric field. So, we have uniform electric and magnetic field, right. Now, you have a charged particle, say Q, you released it from rest, that means initially it is not moving. So, you have the charged particle and you are releasing it. So, initially it has no direction of motion. Now, when you release it, which direction it will move, that is very, very important. What are the forces acting on it? So, there will be only one force act on this charged particle, that is the electric force. Okay, there is no force on a static charge due to a magnetic field. Magnetic field cannot exert or cannot apply any force on a static charge. That is very, very important. Charge, magnetic force will only be active on moving charge. Static charge does not experience any force. So, when the charge is released, it will experience as a force in this direction, which is given by Q into E. Okay, if the charge is positive, it will move in the direction of electric field. If the charge is negative, it will move in the opposite direction of electric field. I am assuming, for simplicity, I am assuming this is a positive charge. Okay, so the charge will move in the direction of electric field. Now, as soon as the charge starts to move, the magnetic field will try. The magnetic field will try to apply force on this moving charge, but will it be able to apply the force on it or not? That is the major question. So, let us see the magnetic force. This is electric force. What is magnetic force? Magnetic force, we just see that it will be Q V B sin theta. Okay, now what is theta here? That is the $1,000,000 question. So, this is the direction of motion. So, charge initially will move in the direction of electric field. So, in the direction of electric field means magnetic field is also in the same direction. So, the angle will be 0 degree, it is not 180 degree by the way, it is 0 degree. Okay, 180 degrees in the opposite direction. Anyway, does not matter. 180 degree will also give you 0. So, sin theta sin 0 will give you 0 value. In case of negative charge, it will be in the opposite direction, 180 degree angle, sin 180 degree is again 0. So, both cases you will get magnetic force is 0. So, no magnetic force will act and the charge will continue to move in a straight line. The charge will continue to move in a straight line. It will be not a helix, it will not be a circle, it will not be a cycloid, it will be a straight line. Again, very intelligent question. A galvanometer can be converted into a voltmeter by connecting a similar question. Again, galvanometer to voltmeter, high resistance in series is the answer for this question. The dimensions of magnetic moment is. So, dimensions of magnetic moment, let us understand what is magnetic moment. The magnetic moment is given by current into area. Okay. Number of turns is there, but mainly current into area. Okay. So, what is the number of turns is dimensionless quantity. So, that is why we are not including that. So, what is the dimension of current? Dimension of current is A ampere. What is the unit of area A? Area is dimension is L square. So, dimension of magnetic moment is A L square or L square A. Very simple question, simple answer. Now, a current I flows along the length of an infinitely long straight thin walled pipe. Then the magnetic field. So, we have a thin walled pipe. Thin walled means the wall of the pipe is very thin. Okay. And the pipe is infinitely long. So, very long and the current is inside, it is hollow. Okay. Inside part is hollow, nothing is there. At all points inside the pipe is same but not 0. So, if you consider any point inside, what will be the magnetic field? So, any point inside the thin wall, if you consider an Amperean loop and apply Ampere's current law, Ampere's law, that states that magnetic field times area is basically integral B dot dA equals to mu naught I. Now, for simplicity, if the area is now not changing, then we can write this equation as B into area equals to mu naught I. Right here I is, it is similar to the Gauss's law. Okay, it will be I enclosed. I enclosed. Now, if you see that inside I enclosed is 0 because all the current is flowing through the surface. All the current is flowing through the surface of the pipe. Inside the pipe there is no current. So, I enclosed is 0. So, magnetic field inside will be 0. Magnetic field inside will be 0. Okay. At any point inside the pipe is 0. This is the correct answer. Is 0 only on the axis of the pipe? Not correct. Is different at different points inside the pipe? That is also not correct. It will be 0 inside the pipe because current enclosed inside the pipe is 0, that is why magnetic field is 0. Parallel currents are dash and anti-parallel currents are dash. So, you have to understand parallel currents attract and anti-parallel currents repel each other. Parallel currents, if the currents are in the parallel direction, that is they are moving in the same direction, they tend to attract each other. Whereas, anti-parallel currents, that means currents are flowing in the opposite direction. So, it will they will repel each other. Okay, if you apply the formula, you will find that they repel each other. Okay, so, parallel currents attract, opposite currents repel. So, option C is correct for this question. Very interesting, important question. Okay. A charged particle moving perpendicular to a magnetic field, if its speed increases then its radius. So, let us understand charged particle moving in perpendicular to magnetic field. So, magnetic field in this direction and velocity is in this direction. So, what happens to its radius? We will do the derivation in a while. Okay. Radius is directly proportional to velocity. Okay. mv square by r is equal to QVB. So, from there you can calculate that it is directly proportional to velocity. So, if velocity increases, the radius will also increase. Okay. So, if speed increases, the radius will also increase. Okay. Next, fill in the blanks, 5 fill in the blanks. Now, fill in the blanks are generally not important according to the last year's blueprint might change, but this is a midterm exam. So, not midterm, sorry, unit exam, unit test exam. There might be possible that they will ask you one fill in the blanks from this chapter as well. So, there is no harm practicing few more fill in the blanks, and obviously fill in the blanks and MCQs are always interchangeable. Which question that can come as a fill in the blanks can be asked in a MCQ as well as MCQ questions can also be turned into a fill in the blanks question. When the charged particles move in a combined magnetic field, magnetic and electric field, then the force acting is known as. So, combined electric and magnetic field is definitely called Lorentz force. Let us see Lorentz force option is there or not. Yes, it is there, Lorentz force. So, first answer is Lorentz force. The direction of the magnetic field due to a current loop is found using the, so direction of magnetic field due to a current loop is found using the Ampere's circuital law or Laplace's law or right hand thumb rule. There are 3 rules are there. So, direction of magnetic field due to a current loop. So, whenever you are finding the current direction of magnetic field due to a current loop, there are basically 2 laws, right hand thumb rule and Ampere's swimming rule, not Ampere's circuital law, Ampere's swimming rule. If you have studied that in the when you are a kid, that was there in the small children's book, class 6, class 7th, that you are swimming on the direction of the current, then the force will act on the magnetic field will be certainly on your right hand side. So, that was Ampere's swimming rule, but that is no longer used. The thumb rule is much easier. So, it is basically right hand thumb rule. Right hand thumb rule. So, if this is the direction of current, if your thumb represents the direction of current, then if you rotate your fingers along the direction of current, then that will give you the direction of magnetic field. So, right hand thumb rule is done. So, let us cross that as well or mark, underline it. So, I request whenever you answer fill in the blanks, try to mark it so that you are sure which are the options that is already used, which are options that is already in your hand. Next, the alternative form of Biot-Savart's law. The alternative form of Biot-Savart's law. So, now if you remember that in some cases, for example, the magnetic field due to a straight wire, we can use Biot-Savart's law, we can use Ampere's circuital law as well. So, Ampere's circuital law and Biot-Savart's law, they are one and other the same thing. They are talking in a some different, the language is different, the mathematics is different, but they are basically the same law. So, Ampere's circuital law is the alternative form of Biot-Savart's law. Current carrying circular coil is equivalent to, so current carrying circular coil is equivalent to a dipole. Okay, this is the dipole, magnetic dipole. It is basically a magnetic dipole. So, current carrying circular coil is equivalent to magnetic dipole. In fact, if you remember that solenoid can be considered to be a magnet because it consists of multiple loops, multiple coils. Okay, that is why it gives you a magnetic field similar to that of a magnet, right. So, current carrying circular coil is same as a magnetic dipole. Resistance of an ideal voltmeter is infinity. Resistance of an ideal voltmeter is infinity and ideal ammeter is 0. Okay. Resistance of an ideal voltmeter is infinity, resistance of an ideal ammeter is 0. So, if you are connecting something in parallel to measure the voltage, okay, then it should have, ideally it should not draw any current from the circuit, so that the actual voltage is accessible to you. That is why the ideal voltmeter should have very high resistance, which is equivalent to infinity, but you need some small amount of current pass through it. That is why you cannot keep it infinity, but ideal voltmeter can have a infinite resistance. Next, Let us look into the 2 marker questions. First, you have to understand that from this chapter a lot of 2 marker and 3 marker numerical questions can come. Okay, there is no such history of coming 5 marker numerical question from this chapter, but 2 marker and 3 marker numericals are very common from this chapter. We will see some of the most commonly asked question in this department 2 marker and 3 marker from this chapter. Let us see. A long air core solenoid of 1000 turns per unit length carries a current of 2 ampere. Calculate the magnetic field at the midpoint of the axis. So, long air core solenoid, the turns are given, the current is given. Okay, calculate the magnetic field. So, what is the formula for magnetic field due to a current carrying solenoid? It is mu naught Ni. Okay, mu naught Ni. So, let us put those values. What is mu naught? Mu naught is, now if you remember, mu naught is permeability of free space, right? Mu naught is permeability of free space, epsilon naught is permittivity of free space. It is 10 to the power of minus 7 SI unit. Okay, so mu naught is basically 4 pi into 10 to the power of minus 7. Right, now put the value over here, 4 pi into 10 to the power of minus 7. N is given 1000, 1000 can be written as 10 to the power of 3. Okay, 1000 can be written as 10 to the power of 3, right. So, that is what we have written, because 10 to the power, it is helpful for us to cancel. Current is given as 2 ampere. So, just 2 ampere, no milliampere, no nothing else. So, just 2 ampere. So, you will get 8 pi into 10 to the power of minus 4, minus 7 minus plus 3, it will get minus 4, okay, and it will be, the unit will be Tesla. SI unit, everything is in SI. So, magnetic field will come out to be 8 pi into 10 to the power of minus 4 Tesla. Now, it is up to you, if you want to put the value of pi and multiply it and get the value, that is okay, but if you leave it over here also, you will get full marks. They will check whether you know the formulas and if you have put the values correctly, and then you have calculated it properly or not. That is what they are going to check. Next, another numerical question. A moving coil galvanometer gives a deflection of 10 divisions when 200 microampere of current is passed through it. Find the current sensitivity of the galvanometer. I think this question is from one of the previous year's model paper, and as you can see, this is a very simple question, nothing difficult in this. So, 10 division, and what is the current? Current is 200 microampere. So, what is the sensitivity means? Sensitivity means if for one division of deflection how much current is required, or how much current can give it a one deflection. So, that is the basic sensitivity means. So, one division means what? This is just a unitary problem, 200 divided by 10 microampere, nothing here. So, 20 microampere. So, the sensitivity is given by 20 microampere per division. This is very important. The unit will be per division, because by using unitary method you have calculated the current required for one division. That means it will be per division, 20 microampere per division, that is the current sensitivity of this device, as simple as that. Next, when does current carrying conductor placed in a uniform magnetic field experience maximum force and minimum force? So, if you have followed my MCQ sections, there I have discussed the force acting on a current carrying conductor placed in a uniform magnetic field experiences a force given by the equation F is equal to BIL sin theta, Bill sin theta. Okay, you can remember Billy. Okay, Billy means cat. So, or you can remember Bill Clinton. Okay, that is what I was, when I was studying, Bill Clinton was the president of America, now it is someone else. So, that is how we used to remember, or you can remember Billy, cat, or whatever is suitable for you. Okay, Bill sin theta. okay, Bill sin theta. Now, the force will be maximum when sin theta is 1, force will be maximum because B, I, L are constant, okay, for a particular given current carrying conductor, and magnetic field is fixed, length is fixed. So, only sin theta can vary. So, force will be maximum when theta is 90 degrees, that is sin theta is 1. So, sin theta equals to 1. So, when sin theta equals to 1 means theta is 90 degrees, force is minimum, force is minimum when theta is 0 degrees, that is sin theta is 0, okay, sin 0 theta 0, right, sin theta 0 means theta equals to 0. So, that is how you can answer this question, very easy and easily answerable question. Now, F is equal to Bill sin theta, you have to mention this formula and then you have to write down these two conditions. Next is write the expression for magnetic force per unit length between two long straight parallel conductors carrying current. Give the nature of the force between the two parallel conductors carrying current in the same direction. So, first of all, force per unit length between two current carrying conductors is given by mu naught by 2 pi Ia Ib by d. D is the difference distance between the current carrying conductor. If you draw a simple diagram, that will very, very helpful, okay. So, Ia, Ib, and this is the distance d. We will do the derivation, do not worry about it, we will do the derivation as well. Parallel currents attract and anti-parallel currents repel. So, how they behave, that is very, very common. Parallel currents attract and opposite current repel each other, simple. Next, a galvanometer has a resistance. Now, this is a 3 marker question. As soon as galvanometer to voltmeter conversion or galvanometer to ammeter conversion questions are being asked, they are 3 marker question. A galvanometer has a resistance of 12 ohm and meter shows a full scale deflection for a current 3 milliampere. How will you convert it into a voltmeter of range 0 to 18 volt? So, here we are converting a galvanometer into a voltmeter. So, what you have to do, you have to connect a high value resistance in series. Okay, for converting a galvanometer into an ammeter, you have to connect a low value resistance in parallel, right. Now, full scale deflection means, what is the meaning of this? Full scale deflection for a current. This is very, very important. It is valid for all types of conversion. Full scale deflection means the maximum current that can pass through the galvanometer is 3 milliampere. The maximum current that can pass through the galvanometer is 3 milliampere. It cannot withstand more than this current. If more than this current passes through the galvanometer might get damaged. Okay. So, this is the maximum current. The resistance of the galvanometer is given 12 ohm. Now, the range of the voltmeter is 0 to 18 volt, right. For 0 volt reading, what should be the current in the galvanometer? For 0 volt reading, what should be the current in the galvanometer? Obviously 0, right. 0 current means 0 deflection, means obviously it will show 0 reading. Now, for maximum value 18 volt, what should be the current in the galvanometer? For maximum voltage, it can measure 18 volt. The current also should be the maximum value, that is 3 milliampere. That is the major thing that you have to understand. Basically, you have to understand that for maximum voltage, this is the current that should pass through the galvanometer. Okay. So, from here we can say that from Ohm's law, V is equal to current into resistance of the galvanometer plus external resistance that you have applied. Okay. Now, what is the voltage over here? Voltage is maximum, that is 18. Current is what? Current is 3 milliampere. Milliampere means 10 to the power of minus 3. Milli means 10 to the power of minus 3. So, 12 plus R. Now, let us simplify this. So, 12 plus r equals to 18 by 3 into 10 to the power of minus 3. So, it will be 6 and 10 to the power of minus 3 it will go up and become plus. So, it will be 6 into 10 to the power of 3, that is 6000. 10 to the power of plus 3 means 6000. So, r will be 6000 minus 12, that is 5988. So, the resistance of the external resistance, if you connect a resistance in series, you have to mention that in the answer. So, an external resistance of this ohm is connected in series, okay, in series, because you are converting it from a galvanometer to a voltmeter. Okay, so, you have to mention this combination as well, in series or in parallel, that is also has to be mentioned. If you connect this into a parallel, then it will not make any sense. So, 5988 ohm in series should be the answer. Next question, state and explain Biot-Savart's law with a suitable diagram. So, this is the diagram, very common diagram, okay, a current carrying wire, this is a current element IDL, okay. If you see that there is a small arrow over here, right, and this is the point where you are measuring the magnetic field, and it is the current element, the direction of current element, and it makes an angle theta with the direction. Okay. So, the magnitude of magnetic field at any point P due to a current element dl is directly proportional to the strength of the current, directly proportional to the length of the current element dl, directly proportional to the sine of the angle between the current element and the line joining the given point and midpoint of the current element, okay, and inversely proportional to the square of the distance between the current element and the point. Okay, this is the Biot-Savart's law. Some people just write the mathematical form. Now, mathematical form is optional. If you are writing the formula correctly, you may not need to write the mathematical form. dB is equal to mu naught by 4 pi I dl sin theta by r square. Okay. So, this is the small magnetic field due to a small portion of current carrying conductor. Okay. Now, the wire may not be uniform. Okay, it can be complicated structure. For that Biot-Savart's law is used, okay, and it is more general form is this. This is optional, but if you write it, you will get noticed by the teacher. But this portion is compulsory. Some student write it like that, the dB proportional to the current I. That is also fine. Okay, then you have to mention what is dB, what is I, and this point has to be mentioned, the magnitude of a field at any point P due to a current element. This has to be mentioned. Okay, this much is compulsory to write. Next, derive an expression for angular frequency of revolution / radius of circular path for a charged particle moving perpendicular to a uniform magnetic field. So, we have a magnetic field, okay, magnetic field, say into the page of the paper, okay, and a charged particle is moving in the perpendicular direction. Okay. So, they are basically perpendicular. Okay, one is into the page of the paper, another is this. So, it will be the direction of motion. Now, suppose at some point its speed is v. At some point its speed is v, the charge which is rotating is given by, say, q. Charge is given by q. Now, what will happen in this case? If it is rotating in a circular path, there has to be one force that is acting on it, and that force is called centripetal force Fc. The radius of the path, say, small r. So, we are trying to find this radius as well as frequency of Angular frequency means with what speed it is rotating, this is called angular frequency, which is given by the symbol omega, right. So, what is centripetal force? And centripetal force is a force which is required to perform a circular motion. Centripetal force is required to perform circular motion, and this centripetal force has to be provided by some interacting forces. Okay, centripetal force has to be provided by some interacting forces. If the interacting force cannot provide the centripetal force, then the circular motion is not possible. Okay, clearly understood. For example, if a satellite is rotating around the earth, okay, the satellite requires a centripetal force. Who provides that centripetal force? The gravitational force between the earth and the satellite provides the required centripetal force. In case the required centripetal force is not enough, then the satellite will slowly it will come back to earth and it will fall back to earth. It will not be able to rotate on the circular orbit. Okay, so centripetal force has to be provided, and based on that a lot of calculation that what orbit it should rotate, what will be the rotation of the motion, etc. are calculated. Okay, so it's very important force. So what is centripetal force? Normally centripetal force is given by mv square by r. Okay, mv square by r. Or you can write this in another form, we will not use it right now. Okay, and someone has to provide the centripetal force. In this case, who is providing the centripetal force? The magnetic force. Centripetal force cannot generate itself. Okay, it has to be provided by interacting forces. Okay, if you are taking a turn on a banked road, then the friction has to provide the required centripetal force. Okay, or maybe the weight of your body has to provide the required centripetal force, right. So now in this case the magnetic force is providing the required centripetal force. What is magnetic force? QVB sin theta, in this case perpendicular, so theta is 90 degrees, so sin theta is 1. So from that configuration we can say that these two forces must be equal. So from here we can write mv square by r equals to QVB. Okay, from here first part we will calculate the radius. Any one of them will come, not both of them. Okay, first we will calculate the radius. So you can see that this is also V, this is also V, one of the V is cancelled. So from here we can say R equals to mv by QB. Okay, cross multiplication, R goes here, I am writing the R first. So R equals to mv by QB. So this is the first expression, this is the radius of the rotation. Okay. Now what is the angular frequency? For that you have to put a relation that V equals to R times omega. V equals to R times omega. Okay. So what is the omega over here? Omega is equal to V by R. Okay. So from here if you put okay, no, not put over here, let me not use this. We will simply replace the value of V with omega, this conversion factor. So R equals to m into R omega by QB. Okay, or omega equals to QBR divided by MR. R cancels. So omega equals to QB by M. This is the expression for angular frequency. This is the expression for angular frequency. Now if you are only doing angular frequency calculation, if you are doing only angular frequency calculation, you need to replace this value in this equation directly and you will get this equation. Okay, but if you are calculating the radius, then this is the flow. If you are using the V is equal to R omega, you should simply replace it over here, and from here you will get this. Clear? All doubts? If you have any other doubts, please mention that in the comment section of this video. I will try to incorporate that during my live session. Okay? Now let us move on to the next question. What is Lorentz force? Write its expression and explain the terms. force acting on a moving charge particle in the presence of electric and magnetic field is called Lorentz force. Okay. So, as I said, Lorentz force is when magnetic and electric both are present, okay, and it is called Lorentz force. Expression is F is equal to Q into E plus Q into V cross B. Here Q is the charge, okay, E is the electric field, V is velocity of the particle and B is the magnetic field. You have to mention that. 3 marks is there. So, 1 mark for stating the statement, 1 mark for the equation and 1 mark for declaring the variables properly. Next, how can a galvanometer be converted into a voltmeter? Explain with diagram. So, this is a diagram for conversion of voltmeter into galvanometer. As you can see, galvanometer has an internal resistance which is basically given by Rg. R is an external resistance that you have to connect in series. A voltmeter should have a very high resistance as it is connected in parallel in the circuit. This is a statement which why you have to have a voltmeter of very high resistance. A galvanometer is converted into a voltmeter by connecting a suitable high resistance in series with it. This way the overall resistance of the galvanometer voltmeter remains high. So, if you add a very high resistance with a galvanometer, you can convert the galvanometer into a voltmeter, okay, so that its overall resistance remains very high. How can a galvanometer be converted into an ammeter? Explain with diagram. So, similarly, because ammeter is connected in parallel, ammeter is connected in series with the circuit, ideally it should have a 0 resistance, practically very low resistance, okay. So, an ammeter should have a very low resistance as it is connected in series in the circuit. So, why it is so? Why voltmeter on ammeter, or why connecting in parallel or series depends? I am just giving you one example. Okay, this is very critical to understand. If you understand this right now, you will never forget. So, a galvanometer, suppose I have built up a circuit, I designed a circuit and I want to measure the current in the circuit. Now, if my voltmeter or ammeter that I am connecting is not correct, okay, voltmeter has a very low resistance and ammeter has a very high resistance, then what will happen? The current that I am trying to measure will not be the same while I am using this device. This device I am not going to use for eternity, right. For example, if you are using a charger in your mobile phone, is there a voltmeter and ammeter connected there? No, right. So, the resistances and the components are designed such a way that when they are measured using the voltmeter and ammeter, you got this particular values. Now, you know that even if you without the voltmeter and ammeter, they are actually giving you the correct value, value for charging your device. Similarly, so actual practical uses, voltmeter and ammeter are not used, they are only used in the testing phase. So, if you get a wrong result during the testing phase, then your design may not work in the practical purposes. That is why ideal voltmeter should have a high resistance and ideal ammeter should have a low resistance, so that it does not affect the original resistance of the circuit. Now, in series combination we know that resistances gets added. So, lower the resistance, better it is, it will not change the original resistance, and for parallel combination we know that the resistances are inversely gets added. So, that means higher the resistance, it is very highly possible that the original resistance value remains the same. That is why this combinations are connected like this. Voltmeter is a device to measure voltage, that is why it is connected in parallel. Ammeter is a device which measures the current, that is why it is connected in series. Now, if you want more discussion on this, I will do that in future one of my Sankalp videos. When this topic comes over for discussion, I will do detailed analysis, detailed discussion on this conceptual understanding of this. Okay, but for now you have understood why the basic requirement is that. Now, it is achieved by connecting a suitable low resistance S in parallel. This is called shunt. With the term for this is called shunt resistance. Shunting means when a current is passing through a galvanometer, it is not entire current is allowed to pass through the galvanometer, some of the current are passed through this shunt resistance. So, basically it is siphoning the current, it is basically taking out the excess current and allowing the excess current to pass through this, that is why it is called a shunt resistance. Okay. With the galvanometer, this way the overall resistance of the ammeter remains low and the galvanometer is converted into an ammeter. State Ampere's circuital law and arrive the expression for magnetic field due to a long straight current carrying wire. So, first we will use we will check the Ampere's law. Ampere's law states that the line integral of the magnetic field around any closed loop is equal to mu naught times the total current passing through the surface, and obviously the expression is B dot dl equals to mu naught I. Now, this is a 5 marker question. So, this is not the answer, you have to also find the expression for magnetic field due to a long straight current carrying wire. So, we have to consider a very long straight current carrying wire and we have to apply the Ampere's circuital law to find the magnetic field at some point P, at a distance r. Now, similar to that of Gauss law, when we are applying Gauss law for a infinitely long charged wire, we consider a cylindrical symmetry, because for Gauss law we need a closed surface. For Ampere's law we do not need a surface, we need a loop. Okay, it can be a square loop, it can be a circular loop, more symmetrical is better. Okay. So, circle is more symmetrical than a square, so we will consider a circular loop, okay, of radius r. Okay, a circular loop of radius r, try to draw it a little bit better than me in the exam. Okay, this is the radius, current passing through the wire is I. Okay. Now, we will apply the Ampere's circuital law for this particular case. Now, if you see that this point, all the points on this circle are at equal distances, this is equal distance, this is equal distance, all points are equal distance, right. This is a 3-dimensional picture, so it may not appear equal distance, but if you consider a circle, okay, circle have all the radiuses at equal distances, right. So, basically that means that magnetic field is symmetrical along the loop. So, if the magnetic field is symmetrical, that means it should have the constant value. So, magnitude of the magnetic field should be constant. Direction wise it will change, direction wise the direction of magnetic field will change because it is a vector quantity, but magnitude wise the magnetic field will remain constant. So, what we can write from Ampere's circuital law, we can write B dl equals to mu naught I. Why B outside of the integration? So, if it is a constant, then it can come out of the integration. If it is a constant, it can come out of the differentiation, right. Same logic, because of symmetry, magnetic field is constant across the loop. So, you have to mention that, by the way. Okay. So, current carrying wire, let us construct a circular Amperian loop of radius r. We are trying to find the magnetic field at a distance r from the loop, okay, and the diagram is obviously compulsory. Now, due to symmetry, due to circular symmetry, magnetic field is constant at all points on the loop, then we can write this, or B into, now what is close integral dl? This is the symbol for close integral. What is the meaning of close? Close means if you start at this point and if you are, after traveling the entire path, if you are ending at the same point, then it is called a close integral, close path. Starting point and ending point are same, then it is called a closed loop, closed path. So, what is, by the way, dl? dl is a small portion, right, small portion of this loop. And what is the basic significance of integration? Integration basically signifies addition. Integration basically signifies addition. So, integral dl means if you take small portion of this dl and if you add all the portions, all such possible portions in this circle, then you will get close integral dl. So, basically that means that it is the circumference or perimeter of the circle, okay, perimeter or circumference of the circle, right. So, what is the circumference of a circle? Circumference of a circle is 2 pi r. Circumference of a circle is 2 pi r, area of a circle is pi r square, right. So, from here we can write this is equals to mu naught I, or B equals to mu naught by 2 pi I by r. So, this is the expression for magnetic field due to a straight current carrying wire. Very simple derivation, very easy derivation, some textual description required, and this is obviously a textual answer. Okay. You have to describe the image. Describe the image is must. Okay. Clear? Now, let us move on to the next question. Derive an expression for the magnetic field at a point on the axis of a circular loop. So, we have a circular loop, current carrying circular loop obviously. Suppose the current passing through this in the loop is I, and we are trying to find the magnetic field at a point on the axis of the circular loop, say at a distance, say x. Okay, we are trying to find the magnetic field at a distance x. Now, for that what we have to do? We have to take a small portion of this loop dl, and we will try to find the magnetic field due to this loop. Okay, magnetic field due to this loop. Okay. And if you apply the Biot-Savart's law, what is the formula for magnetic field due to a small current element? Magnetic field due to a current element is given by dB equals to mu naught by 4 pi I dl sin theta by r square. Now, what is r over here? The r over here is this, and the radius of the loop is given by capital R. Now, if you see that this is a right angle triangle. So, right angle triangle means you can apply Pythagoras theorem to find this distance, r square plus x square. Okay. Now, what is the angle theta here? Angle theta, so this is the direction of displacement vector, and the current is being carried in this direction. So, if you consider the direction of current element and the direction vector, they will be perpendicular direction. Okay. So, perpendicular direction because it is a tangential. So, if you are considering this is a 3-dimensional picture, again I am trying to draw in a 2-dimensional way because it is in a tangential direction. The sin theta is 90 degrees, and 90 degrees means, so this is the direction of the dl, this is the direction of the position vector. So, they are in the 90 degrees angle. So, that means sin theta is 1. Okay, sin theta is 1. Also, what is the direction of this magnetic field dB? The magnetic field dB will be such a way, there are two components. Okay. One component is, so suppose this is the direction of dB, not this, sorry, dB will be somewhere here, mutually perpendicular to both of them, mutually perpendicular to I cross dl, right, I cross dl, that is why it is I dl sin theta. Okay. And so, it will be mutually perpendicular to the direction vector as well as dl vector. Okay. So, this will be the direction of dB. Now, this is the direction of dB means if you take another component exactly diametrically opposite direction, okay, then the dB will be somewhere in this direction. So, this will be also magnitude wise same, because I is constant, mu naught by 4 pi is constant, sin theta is 1. So, it will be mu naught by 4 pi I dl by r square. okay, sin theta is 1. Okay. But if you consider any one of the component diametrically opposite component, what you will find that magnitude same, but the direction will be different. So, what is the case over here? Okay. So, this is dB, this is also dB. So, if you take components, one component will be along y axis, one component will be along x axis, right. Now, y components, they will be equal but opposite direction. So, they will cancel each other, only the x component will remain, only the x component will remain. So, only dBx will left, all other components, they will cancel each other. It is not for only these 2 points, any 2 points if you consider diametrically opposite, they will cancel each other. The y components will be cancelled, only the x component will left, right. Now, if this component angle, if you consider phi, if you consider this angle to be phi, then by geometry you can show that this angle will also be phi. Okay, this angle will also be phi. Okay. So, what is dBx by the way? dBx is nothing but dB cos phi, dB cos phi. Why? This is the adjacent component, this is phi, this is also phi. Okay. So, dB cos phi. Okay. So, we are basically trying to find this dBx component, not the entire dB. So, dBx equal to dB cos phi or mu naught by 4 pi I. You have to practice this derivation. This derivation is very important. It is not only important for your board unit test exam, but for your board exam as well. And this is one of the most asked question from this chapter. So, you have to practice this derivation. This is not a super easy derivation, but it is one of the most asked derivation. That is why you have to practice this derivation at least 3 times, so that you are confident that you can answer it. Okay. Now, let us see the value of cos phi. So, this angle I said this angle is phi, this angle is phi means this angle is also phi. Now, so cos phi means what? If you remember my mnemonics, some people have curly brown hair. Curly means cos, brown for base and hair for hypotenuse. So, base by hypotenuse. So, what is base over here? Base is the adjacent side. So, r is the base. What is hypotenuse? Hypotenuse is small r. Okay. So, this is the basic value. Now, let us simplify this. So, from here we get mu naught by 4 pi I r by r cube dl. Okay. Now, as you can see, everything is constant except this dl. So, when we are trying to find the total bx, which is basically integration of dbx, which is basically this thing is constant. So, they will come out of the integration mu naught by 4 pi okay, I r by r cube integral dl. Okay. So, what is integral dl? Again, dl is the small portion. So, integral dl means the entire addition of the all small portions, which is again the circumference of the circle, right. Now, let us put the values. Mu naught by 4 pi okay, I r by r cube into what is dl? dl is the circumference of this circle. So, it will be 2 pi into r. Okay. So, 2 pi gets cancelled over here, you get 2. Now, we have to put the value of r as well, and we will get the answer as mu naught by 2 I capital R square. Why R square? This R times this R square, and R cube means what? R square plus x square to the power 3 by 2. Okay. Square root means to the power half. square root of any number is square root of to the power half, right. So, r square plus x square root means to the power half, and we had 1 cube over here. So, it will be to the power 3 by 2. Now, there is a special case for this derivation as well. If it is not asked, you do not need to show it. The special case is when this point is located at the center, when this point is located at the center of the coil. For center of the coil, x will be equals to 0. For center of the coil, x will be equals to 0. So, for that you have to get B center, and that is mu naught by 2 I r square by r cube. Okay. This x becomes 0. So, r square to the power 3 by 2, 2 cancels, you get r cube, or this becomes mu naught by 2 I by r. Mu naught by 2 I by r, this is a special case. If not asked, you do not need to answer it. Clear? Very important, very important derivation. If you have this chapter in your syllabus, this is one of the very important derivation. Now, let us move on to the last question of this chapter. Derive an expression for force per unit length on two infinitely long thin parallel straight conductors carrying current and hence define ampere. Okay, so, first this is very common, this is also very important derivation. Okay, two parallel current carrying conductors. So, we say this is current wire 1, this is wire 2, current through this say IA, current through this say IB, the distance between them is given by say D. Okay. So, first how to find the force acting between them. First we will try to find the magnetic field due to wire 1 at a distance D. Okay. Then we will use the formula BIL sin theta. In this case sin theta is again 1. So, we have to and this is infinitely long wire, but when you apply the formula BIL sin theta, for that you have to consider a finite wire. So, we have to consider a finite wire length. For now we are considering the length L for both side. Okay. Now, let us understand what is the magnetic field due to a infinitely current carrying wire at a distance D. So, if you have seen my derivation few moments back, I did that derivation here. It is the magnetic field due to a infinitely current carrying wire mu naught by 2 pi I by r, mu naught by 2 pi I by r. So, this is the first starting point of this. So, magnetic field due to magnetic field due to wire 1 at a distance D is given by mu naught by 2 pi I A by D, I A by D, no square, nothing, simple I A by D. So, this is the magnetic field due to 1. So, what is the force on the second wire? Force on the second wire due to wire 1, that will be B1 I B L. Sin theta is 1, L is the length concerned for this particular case. Now, let us put the value of B1, you get that mu naught by 2 pi IA IB by D into L. Similarly, F12 will be mu naught by 2 pi IA IB by D into L, but in the opposite direction. How can you do that? For that you have to calculate B2 and then again apply the same law. Instead of BA you will be BAB. So, you can write this as due to symmetry. Okay, you can write that because the equation is symmetrical, IA, IB, D, everything is interchangeable. So, even if you interchange A and B, you will get the same expression. So, this is a symmetrical force, right. So, magnitude wise we can write this force is equals to F21 equals to F12. Now according to the third law they are in the equal but opposite direction. So if this force is in this direction, this will be the force on this. So this is F12, this is F21. They are equal but in opposite direction from third law. That's why we are taking magnitude, and that is given by mu naught by 2 pi Ia Ib by d into L. Now here this L, this small l was not given in the expression. It is said that long, infinitely long. So L should not be here. So for that we define a quantity called force per unit length. Force per unit length. Force per unit length means you have to divide this L in this expression and find the force. Okay, so it will be mu naught by 2 pi Ia Ib by d. Okay, so this is the expression for force per unit length. Okay, force per unit length between two current carrying parallel wires. This derivation is also very important. You have to practice 2-3 times. Also they asked you the define the ampere. Define the ampere. How can you define ampere? To define ampere, what you have to do? You have to put Ia equals to Ib equals to 1 ampere, d equals to 1 meter. Then what is force per unit length? Force per unit length will be mu naught by 2 pi, which is equals to 2 into 10 to the power of minus 7 Newton. Okay. So ampere is the current when flows through each of the two parallel conductors. So ampere is the current when it passes through each of the parallel current carrying wire, okay, kept at a distance of 1 meter, experiences a force of 2 into 10 to the power of minus 7 Newton per meter. So Newton per meter because it's a force per unit length, that's why it will be Newton per meter. Okay. So this is the basic chapter questions, all the important questions along with the theory and their explanations. I hope you enjoyed today's session, and if you have any doubt, any questions, please do mention in the comment below. I will try to cover as many questions as possible. I will be back very soon. Till then, bye.